Hey, I just wanted to pass on a little secret to you guys about memorizing some of these laws or some of these rules with derivatives having to do with exponentials and logs. So let's start off with this first fact. So what is e to the ln of a? So if you guess that it's a, you were right. It's equal to a. So if we have e to the ln of x, because of the inverse property of the two, then we end up with x. So whatever happens to be in that position, e to the ln of maybe dollar symbols is more dollars, right? So anyway, my point is that e to the ln of a is equal to a, right? So now we can take this y is equal to a to the x, because remember this week we're working on derivatives of logs and exponents that look like this. So this is the exponential a to the x. So how about if I rewrite this then as y is equal to e to the ln of a, and then put that to the x power, like so. Okay. Makes sense? That's a to the x then. All right, and next, we're going to take this and we're going to say, all right, well, I can do that. How about if I use one of the exponent rules and make this e to, oops, sorry, not an e to the ln of a times x. So if it was e to the 3x, then it's similar. It's e to the ln of a x, ln of a being a constant, okay? So then next, and next, we would then say, all right, take the derivative. So if we do, we get dy dx is equal to the e to the u times du dx form. Yes, to use chain rule with this. And so then we end up with e to the, here, u is equal to ln of ax. And then du dx is, of course, ln of a. So we would get e to the ln of ax, put parentheses around there, and then we would have du dx, which is ln of a. Okay, so it's going to be times ln of a. So then we would say dy dx, we've got it then, dy dx is equal to e to the ln of a. Well, wait a minute, that is a to the x, right? Because we could change this very quickly by saying, well, we can take it backwards, right? We can say e to the ln of a, put parentheses around that, and then that would imply the multiplication of the exponents, right? Power of a power. So we would then have a to the x, and then we would have it times ln of a. And that's the derivative of a to the x. So the derivative with respect to x of a to the x is equal to this. Okay? So just showing you how I derived it, because it seems like it kind of falls from the sky sometimes. It's like, what is going on? And it just seems like, wow, there's got to be a way to kind of look at it. So kind of taking it backwards and using the E form derivative makes a little more sense, okay? So that's a little go around, a little secret about E to the ln of a and the derivative of a to the x, okay? Now, the next page, let's look at something else. Let's look at, we've been talking about the derivative. Let's start it like this. We've said that dy dx, we're going to say d dx of log base a of x, and I'll say x instead of u, is equal to what? Well, we said 1 over ln of a, and then it would be times 1 over x, like that. And we often write it like this, 1 over x ln of a, putting the x in front of the transcendental function. Transcendental means it goes beyond algebra kind of stuff. So that's all your trig functions and your logarithms and exponentials. Okay, so we have that rule, we know that, and you go, well, how can we deal with this so that we understand it a little bit better? How are we getting this result? It's we know that the derivative of ln of x is, of course, 1 over x. So how does it turn out to be so similar? Well, remember there was an identity or a log change of, remember this thing? Change of base formula. Trying to make this quick and then it's never quick. Log base a of x then, of course, is equal to ln of x over ln of a. Now you'll kind of see where things are going here. So from this, if I look at saying given an identity or that relationship, then I can start and say, all right, well, then the derivative, if y is equal to log base a of x, and we know already from the lesson dy dx is equal to 1 over x ln of a, right? Or 1 over ln of a times 1 over x. So we could then rewrite this as y is equal to ln of x over ln of a. And then we could take the derivative of that. But before we do, how about if we do one more rewrite like this, 1 over ln of a, and look at that like that, what it is. It characterizes itself as a, well, it doesn't, we do, characterize that as a number, right? And then we have times ln of x. So we have a number times the function ln of x now, so dy dx would be then, of course, that number, 1 over ln of a, times the derivative with respect to x of ln of x. And so we simply get 1 over ln of a times 1 over x, and then that leads to the derivative that we've been talking about, okay? So just a couple of things with how these rules work or why they work, and they're not just, oh, you have to memorize it. You kind of, now you have a connection to why we're getting the result we are. Why are we getting 1 over ln of a times 1 over x? Okay. All right. So that's it. Just wanted to send you a quick video on the derivatives of log base a and the derivatives of a to the x. See if that would help you out. Okay. So I'll see you guys tomorrow.